Good morning. I welcome you all for today's session, K-Map Minimization. So this K-Map simplification, in the previous class we have discussed about Boolean simplification. As I said, there are three types of minimization techniques. First one is Boolean simplification, second one is K-Map, and third one is Queen-Mikulski method, which is also named as tabulation method. So the first one we have discussed in the previous class. Now we are moving to the next minimization technique, that is K-Map. This K-Map technique is very simpler and less error prone compared to the previous method, and it also overcomes the drawback from the first one, because for lengthy simplifications, lengthy expressions, it is very tough to use Boolean simplifications like algebraic laws, theorems, etc. etc. So that is the main purpose. Here we are moving to the next minimization technique, which overcomes the drawback of the previous one. So this is our second technique. So the history of K-Map is, it is also named as K-Map. Karnaugh Map is, it is also named as K-Map. It was introduced by Dr. Maurice Karnaugh in the year 1953. Let us discuss the rules of K-Map. So this K-Map is a pictorial method of grouping together expressions with common factors and then eliminating the unwanted variables. These are some rules which is used for the simplification of expressions by grouping together adjacent cells which contains ones. So we can group the adjacent ones like pair, octet and quad. So the first one is groups may not include any cell containing a 0. Only one can be used. Only one, the cell which consists only one can be grouped. And next, the groups may be horizontal or vertical but not diagonal. So you can see here the groups may be in the right side, you can see it is horizontal and vertical. So that likewise you can group, but diagonal is not allowed as shown in the left side. And the groups must contain 1, 2, 4, 8 like pair, octet and quad. It should not have odd number of ones. The group should be as large as possible. So we have to check first whether any octet, that is 8 number of ones adjacent to each other. If there is no octet, then we have to come for quad, that is 4 number of ones with adjacent sides. If not, only we have to go for pair. So each cell, next rule is each cell containing a 1 must be in at least one group. That is, we should not leave any one left out. Even if there is no pair, if it is not able to pair adjacently, we have to encircle it separately and to be considered as a separate group. That is said to be as, that process is said to be as isolated term. And the group's next rule is the groups may also overlap. So you can see a quad, 2 quads are overlapped here horizontally and vertically. Next one, the groups may wrap around the table like topmost and bottommost and leftmost and rightmost. This type of adjacents is also allowed. And next rule is there should be as few groups as possible. That is, as we discussed in the fourth point, the groups must be simplified as much as possible. So these are the rules which we have discussed so far with the examples. And the types of K-maps are 2 variable, 3 variable, 4 variable and 5 variable. So this is 2 variable which consists of 4 cells, and 3 variable which consists of 8. That is, the number of variables is 3, 2 power 3, and these are the adjacent min terms for 3 variable. And this is 4 variable which consists of 16 cells. So we have 16 cells in row and column wise. That is our midterm and max term. And these are all the variables contains in 4 variable. And this is 5 variable, where the number of cells in 5 variable came up is 32, since the number of variables is 5. So this is the K-Map plot, K-Map for 5 variable. There is only one possibility of grouping 32 adjacent minterms in 5 variable. And here, with our understanding, there are few assessment questions regarding K-Map. I hope now you understood in detail about Karnaugh Map, which is also named as K map. Thank you.